Okay, in this lesson, we're going to talk about the convergence or divergence of the sums of series. So the first rule is that if one series is convergent and another series is divergent, then the sum of those series is divergent. Okay, so let's look at an example. So let's say I have the series from 1 to infinity of 1/3 to the n plus 3/2 to the n. Okay, so if I were trying to determine the convergence or divergence of this series, I would say that this first term is, the series of just this first term is convergent because this is a geometric series with r equal to 1/3, which is less than 1. Then I would say that this second part over here, this is divergent because this is also a geometric series with r equal to 3/2, which is greater than or equal to 1. Therefore, my conclusion is that the infinite series from 1 to infinity of 1/3 to the n plus 3/2 to the n is divergent and my reasoning is that convergent plus divergent is divergent. Okay. All right, so let's go on to our next rule. So let's think about the other two possibilities. So we just showed that, talked about that a convergent series plus a divergent series is divergent. And if you think about what's going on, we've got a finite value plus infinity. Well, infinity plus a constant is still infinity, hence divergent. It then should logically follow that convergent plus convergent equals, well, a finite sum plus a finite sum, that must also equal a finite sum. What about the third possibility, divergent plus divergent? We all know from the many topics we've covered that infinity can have many different meanings. Infinity plus infinity is not necessarily 2 times infinity, and infinity minus infinity is not necessarily 0. And it turns out that divergent plus divergent is inconclusive. You would have to have more information than just that to draw a conclusion, and let me give you an example. So if I consider the infinite series from 1 to infinity of 1 over n, well, we know that this is a p series. P is 1, which is less than or equal to 1, and therefore this is divergent. Adds up to infinity, right? If I took another series, n equals 1 to infinity, let's say I did negative 1 over n. Well, this is also a p series where p is 1, which is less than or equal to 1. Or we could say this is the negative of a p series with p equaling 1, which is less than or negative 1. That's probably more accurate. Negative of a p series with p is 1 less than or equal to 1. Therefore, this is divergent. And we can assume that if this this diverges to infinity, this must then diverge to negative infinity. But if we consider the sums of those, 1 over n plus negative 1 over n, well, then we're going to get 0. But you should logically also be able to conclude that if we had two series that both diverge to positive infinity, we would get infinity here. So divergent plus divergent is inconclusive. You're going to have to do further investigation to draw a conclusion.